This is Algebra Lesson 9-3, multiplying polynomials. The easiest way to multiply two binomials is the distributive property. The distributive property will work for multiplying any type of polynomial, whether it's a binomial, a monomial to a polynomial, a monomial to a monomial. Distributive property is probably the property I use the most frequently when I do this. Okay, so if I'm going to simplify, which basically in this case means multiply, I have 2x plus 3 quantity times x plus 4. Now notice there's no plus or minus signs between the parentheses, so this is why we're multiplying these rather than adding these. Before, the parentheses were just to designate where a polynomial began and ended, so you can do whether or not you had to run the negative sign all the way through a polynomial. Notice here there's no plus signs between the parentheses, so that indicates that we're going to multiply. And I'll show you the method for using distributive property. To use the distributive property, you simply do this. You write the first term of the first polynomial, and write the first term, and then write the second parenthesis, x plus 4. The sign in the second term, so plus 3 times x plus 4. That's how you write the problem out. Now we just simply need to distribute and multiply. 2x times 2x is 2x squared, because remember you add the exponents. 2x times 4 is 8x. 3 times x is 3x. And 3 times 4 is 12. Now we will combine like terms. 8x and 3x is 11x, so we have 2x squared plus 11x plus 12. This method works no matter how large or small your polynomials are, whether it's a binomial times a binomial, which is what we're working with right here, or if it's a binomial times a polynomial of 7 terms. You can still do the same process here. Let's look at the second one. Again, to set it up, you take the first term, and I'm going to highlight it this time. There's my first term, 5m, and I'm going to multiply it by everything in the second parenthesis. So I'll write the entire second parenthesis, 8m minus 1. Then you take the sign and the second term, okay, which would be, in this case, the plus 2, and multiply it by everything in the second parenthesis, 8m minus 1. And now we just distribute. 5m times 8m is 40m squared. 5m times negative 1 is negative 5m. 2 times 8m is positive 16m. 2 times negative 1 is negative 2. Combine your like terms, we have 40m squared plus 11m minus 2. And the great thing about this is most of the time this will be written in standard form once you simplify it. Not always, but most of the time. Last problem here, we're going to do the same process. I'm going to take my first term, 9a, multiply by everything in the second parenthesis, 7a plus 4. Take my sign in my second term, negative 8, and multiply by everything in the second parenthesis, 7a plus 4. So then when I distribute, 9 times 7 is 63a squared. 9 times 4 is 36a. Negative 8 times 7 is negative 56a. And negative 8 times 4 is negative 32. Now we're going to simplify again. 63a squared. Negative 36 minus 56 is negative 28. And then minus 32. This method is the most helpful that I find, and it's the method I use almost primarily. There are other methods, and I will explain those to you as well. You can choose which method you like best. I have no preference which one you use the one that works best for you. Now, besides the distributive property, you can use something called FOIL, or the box method for multiplying binomials. FOIL only works with binomials. That's the drawback here. You'll hear people say, oh, do I need to FOIL this? FOIL only works for binomials because FOIL stands for first, outer, inner, last. That's the F is for first, O is for outer, I is for inner, and L is for last. So FOIL says you take your first terms, Those are my first terms right there. That's the f part. So I would have 4x times 3x, which equals 12x squared. And then I have my outer terms. My outer terms are 4x and negative 6. So my outer terms, that would be O. So I multiply 4x, oops, 4x. Okay, so 4x times negative 6, which would be negative 24x. Then I take my inner terms, that's the inside terms right here, that's the I. So in this case, that would be 2 times 3x, which is 6x. And last but not least, we take what we call the last terms. Last term here, which would be 2 times negative 6, which is negative 12. And then you combine all those. So I have 12x squared. Negative 24 and positive 6 is negative 18x. And minus 12. I'm not a real fan of the FOIL method. I can do it in my head, but I'm not a big fan of it. I prefer the distributive property because FOIL only works binomial to binomial, 2 terms to 2 terms. Anything after that, then you have an inner term and an inner outer term and an outer inner outer, or you have too many inner and outer terms and it gets really confusing. The only thing that stays is your first and last. The second method you can use is something called the box method. Now this method actually was taught to me by my daughter when she went to college because this is what her college professor used. I'd never seen it before. It's interesting. It works really well if you are a very visual person. Basically, you draw a box. I have 4 things here, so I'm going to draw a box that has 4 parts to it. I'm going to have 3x here minus 4, so yeah, I just wrote that term. Then I'm going to have 2x here and plus 5 here. And you basically multiply to your box. So I'm going to multiply negative 4 times 2x, and that becomes negative 8x, and that's there. I'm going to multiply negative 4 times 5, and that's going to be negative 20, and that's there. And then I multiply 3x times 2x, and that's 6x squared. And then I multiply 3x times 5, and that's 15x. And then you simplify. I have 6x squared minus 8 and plus 15, because normally you'll simplify. Normally the terms you have to simplify are in the middle here. Okay? So negative 8 plus 15 is 7. So I have 7x plus 7x minus 20. No matter which method you do, you should still get the same answer. Because if I distributed with this, same problem, I would have 3x times 2x plus 5 minus 4 times 2x plus 5. So I would have 6x squared plus 15x minus 8x minus 20. Notice 6x squared minus 8x, positive 15x minus 20. Same numbers that are in my box here. So I do end up with 6x squared plus 7x minus 20. So I have no preference with which method you use. You can use the box method, you can choose to use the FOIL method, or you can use the distributive method. Most likely when you see me do it, I'll use the distributive method, just because that's what I'm used to, and that's what I like, and it's very simple. All right, now when you multiply a trinomial and a binomial, or a trinomial and a polynomial of any size, the distributive method works best. You can still use the box method. The FOIL method does not work at all. So don't try to do FOIL after a binomial. So if I have this, okay, now I have a trinomial, 3 terms, times a binomial, 2 terms. Okay, again, I'm just going to use the distributive method. I'll use the distributive method one time. I'll use the box method the second time, so that you can see that they both work. Okay, so I'm going to do 3x squared. I'm going to multiply that by everything in the second parenthesis, 2x plus 7. And then I'm going to do negative 2x times 2x plus 7. Okay, and then plus 3 times 2x plus 7. You'll see sometimes you run out of space. If that's the case, a second thing you could do, I'm just going to erase this really quickly. I could do this. I could say 3x squared times 2x plus 7. That equals, leave it there. And then I can say negative 2x times 2x plus 7. I can do it vertically. And then I can say 3 times 2x plus 7. And get the answers that way. That way works too. It saves you a little bit of space so you're not going into your other problems as much. So here, if I distribute this, I'm going to stop drawing arrows pretty soon because they're annoying me. 3x squared times 2x is 6x to the third. Pay attention to signs. 3x squared plus 7 is 21x squared. Then Then I have negative 2x times negative 2x is negative 4x squared. Notice what I'm doing here. I'm lining up my like terms. Negative 2x times 7 is negative 14x. Here I have 3 times 2x, which is 6x, so plus 6x. And 3 times 7 is 21. And notice what I did here is by lining up my like terms, I lined up my like terms vertically. And I wrote them over each other. So now all I have to do is add down. And I'll have my answer. So I have 6x to the third. 21 minus 4 is 17x squared. Negative 14 and positive 6 is negative 8. And plus 21. Okay, simply done. They take space, as you can clearly see. I should have left more space on my board. All right, they take a lot of space to use. Okay, and it doesn't matter if I multiply the trinomial times the binomial or the binomial times the trinomial. In problem number 2 here, it doesn't matter which order you write them in, as long as you multiply everything by everything, you're good. So I'm going to take problem 2 here, and I'm going to use the box method. Since I have a 2-term by a 3-term, I need a box that's 2 by 3. Okay, this way, 3 that way. 3 by 2, it doesn't really matter. This is 6n, this is negative 8, this is 2n squared, this is n plus n plus 7. And I'm just going to multiply. Okay, what you're going to do is you're going to multiply this times this, and this times this, and this times that. Then you're going to multiply this times this times this, and this times that. Okay, I know I do all over the board, and hopefully you can follow this. Okay? And it doesn't matter if you do the green first or the yellow first. Okay, so I can do 6n times 2n squared is 12n squared. 6n times n is 6n squared. 6n times 7 is 42n. Negative 8 times 2n squared is negative 16n squared. Negative 8 times n is negative 8n. Negative 8 times 7 is negative 56. And then I can just combine all my like terms. Oops, I messed up something. 6n times 2n is 12n cubed. I just noticed that right there. 12n to the third. Okay, so I have a 12n to the third. And I have 6n squared and negative 16n squared. Notice you'll notice your like terms line up in a diagonal. Okay? No like term. Those two are like terms. Those two are like terms. No like term. See how they line up in a diagonal, so you're easy to add? Okay, so negative 16 plus 6 is negative 10n squared. Negative 8n and 42 is 34n. And n minus 56. Really, I have no preference which way you do it. Do whichever way works best for you so that you don't mess up. But you'll notice this would be 6n, and we're going to multiply by everything in the second parentheses. So we eventually did that, didn't we? Here's our 6n, and we multiplied by 2n squared plus n plus 7, which is what we would have done if we would have distributed it. So that's why it works. Okay. Do the third problem on your own. Hopefully you'll get an answer. That will be correct. And I'll see you, I'll check your notes in class and make sure you actually did that problem. Let's look at problem 4. Down here. Problem 4 is just a little bit different from problem 3 because we have more variables, let's say. We have 2 sets of variables, an x and a y. So let that confuse you, you're still going to do the same thing. I'm going to take 5x, I'm going to multiply it by 2x squared plus 7y to the third. And I'm going to take my negative 8y. And I'm going to multiply it by 2x squared plus 7y to the third. So if I distribute, I'm going to get 10x to the third plus 35xy. 35xy to the third. Xy to the third. Minus 8 times 2 is 16x squared y. Minus 8 times 7 is 56, 56y to the fourth. And you'll notice here, that's it. Those are the like terms. There's no combining needed because these two middle terms here are not like terms because this is an xy cubed and this is an x squared y. You can't combine them. So this is your final answer right here. It's a very long polynomial, but it's a polynomial nonetheless. It's a polynomial of 4 terms. Problem number 5 is interesting because problem number 5 is a problem that shows you what happens. A lot of times what people will want to do is they'll think of the properties of exponents and they'll think of just distributing the 2, and you can't do that. Because this entire thing is squared. 6x minus 3 quantity squared is how this is read. It actually means 6x minus 3 times 6x minus 3. That's what it means. It does not mean I just distribute the 2 to the 6x and the 2 to the 3. It doesn't work that way. You'll miss middle terms that are really important. So I'm going to have 6x times 6x minus 3 minus 3 times 6x minus 3. So that will give me 36x squared minus 18x minus 18x plus 9. Watch your signs. Negative 3 and negative 3 is positive 9. So this gives me 36x squared minus 18, and 18 is 36. 36x plus 9. And I'm done. If you're multiplying a binomial and a polynomial, sometimes it's easier to put the binomial first, but since multiplication is commutative, it really does not matter. Okay. The reason being is I would prefer, in me personally, if I had this problem right here, number 1, 4b to the third minus 9b squared plus 11, and I'm going to multiply that by 7b squared minus 8, I would prefer to only have to write out plus and minus signs once. So I have a tendency to write 7b squared times 4b to the third minus 9b squared plus 11, and then my minus 8 times 4b to the third minus 9b squared plus 11. Okay, and then distribute like normal. 7 times 4 is 28, d to the fifth, add your exponents, minus 9 times 7 is 63, d to the fourth, plus 77b squared, minus 8 times 4 is 32, d to the third, plus 8 times 9 is 72, 72d squared, plus 80, or minus 88. Now let's combine like terms. Now we have 1d to the fifth, so 28d to the fifth. That guy's gone. I only have 1d to the fourth, so negative 63d to the fourth. That guy's gone. Then I have a 77d squared and a 72d squared. Okay, that's going to be 149d squared. So now those are both gone. Right. Whoops, I just realized I messed something up. I'm going to have to rewrite this. And then I have a negative 32d to the third minus 88. What did I mess up? I didn't keep it in standard form. I went 5, 4, 2, 3. So I have to write it as 28d to the fifth minus 63d to the fourth minus 32d to the third plus 149b squared minus 88. Then it's in standard form. It went in descending order of a variable. In this case, d. Try number 2 on your own. I will check it during class to make sure that you did it. This is multiplying polynomials. Not a hard concept, but a very important concept. Take your time, work slowly, be careful, and be neat.